I'm Wayne Warren, Chief Architect at RAMA in Seattle. We create database management systems, software that will capture, store, manage, and move information on a computer. I've been doing it for 25 years now. Technology has changed a bit since we started, and I just spent the last 2 years modernizing our main product, RDM Embedded. With today's multiple core computers, high-speed networking, and large storage capacities, we had some work to do to make our database take advantage of everything. The result was something I like to call the distributed architecture. The client-server architecture of the 90s assumed that you had weak clients and a powerful server computer. The distributed architecture places the processing everywhere, on each core and networked computer, leveraging the fast and powerful CPUs, disk drives, and networks that are available everywhere. Distributed computing facilitates parallelism, which is the key to performance in databases. How can I show you what distributed database software does? That's the point of this horizontal scaling demonstration that I'm going to show you now. This is the front-end display of the activity of threads that read and write the database. We're using a computer with two 4-core CPUs and 4 disk controllers and disk drives. Note, though, that 8 cores and 4 disks may just as easily be on 4 different computers that are networked together. Local area networking speeds are such that the difference between this computer and 4 dual-core computers is minimal. We're using just one big computer for convenience. There are 8 threads running an update procedure and 1 read thread that reads 1 set of records. Looking at the demo program again, we see charts for each transaction thread across the bottom. Every second we see how many transactions have been finished by the thread. Across the top we see the total of all transactions of all 8 threads, or the system throughput. The number on top is the average for all 40 seconds that are shown across the screen, which is about 48 transactions per second. The number on the bottom is the most recent value, so it changes almost every second. Of course, read locks interfere with threads that are doing the transactions, and all 9 of these threads wait for the others at various times. I need to mention that all of the transaction threads are using the database on 1 disk, but I can redirect them to use databases on 2, 3, and 4 disks using a technique supported by RDM Embedded called database partitioning. I'll be building this up 1 partition at a time. Let me switch 1 transaction thread so we are using a second partition on a second disk. Now I did auto scale, but it shows that we've gone from around 50 transactions a second to around 100. We are seeing parallelism in action. So let's employ the 3rd disk controller and drive. And a 4th. Now we have 8 threads performing updates on 4 database partitions on 4 disk controllers and drives. The transactions per second went from around 50 to around 200. With a shared resource like a database, that's some amazing scaling. But I've saved the most amazing effect for the last. See the reader thread? It has remained steady at around 6 reads per second, hardly being able to squeeze in between the 8 transaction threads. What if I didn't have to obtain a lock before reading it? Normally, this is required so that it won't see changes half done by the others. But RDM Embedded has a feature called read-only transactions, which are an implementation of a technique called multi-version concurrency control, or MVCC. Basically, this means that the database system will take a virtual snapshot of the database for a period of time long enough for the reader to safely read its data. For this demonstration, one read-only transaction is used for each read thread cycle, so the reader is always seeing all changes made right up to the moment it starts the next read-only transaction. This checkbox changes the reader thread so that it stops locking and starts using read-only transactions instead. The auto-scaling chart had to shrink the original bars to fit the new ones, which are now averaging over 200, or about 25 times more than before. Locking is one way to do things safely, but it sure is costly, isn't it? This is all for real. We would love to show you this live and answer your specific questions or discuss your individual needs. You know your industry, we know databases. Let's put our heads together and create solutions that will work today and tomorrow. You can download our product from the downloads page on raima.com, that's R-A-I-M-A, or contact us directly using sales@raima.com.